Hi guys. Good night, everybody. Just let me know if you guys can hear me before I start, please. All right, great. All right. All right, guys. Again, good night, everybody. Welcome to my second session for the January 2024 CSEC Maths preparation. All right. So we had a session last night. We're going to do some more examination style questions today, right? But today we're going to be using some of my own questions in preparation for that exam tomorrow, right? Um, right. So before I begin, right? Just to let you guys know that my exam preparation for the May June exam, it's usually about 4 months, right? My preparation usually takes about 4 months. I cannot review the entire syllabus in one session, right? So my exam preparation for the May June exams usually takes 4 months. So that's about January right up until May, and these are the subjects, right, that I focus on. I personally teach each of these, right? If anyone is interested in preparation for May June, right, you can always send me a WhatsApp on this number here, right? For those of you who haven't done so as yet, please hit like and subscribe, right? Also, feel free to share my YouTube channel to as much students as possible, right? As I've indicated in the past, I've been doing this about 10 years now, right? I've been providing free videos for the entire Caribbean for the past 10 years, right? So feel free to share to as much people as you want, right? So let's get started, right? So I have a sample paper here, right? This is from my own sample, right? Um, let's make this a little bigger. All right, so we have a question here, right? Question one, like I said last night, is usually about decimals, fractions, and consumer arithmetic. So in this question here, by rounding each number in the expression below to one significant figure, estimate the value of this, right? So I'm going to give you all a chance to actually work this out for me here. I want you all to work out this question based on the fact that we're going to round off everything to one significant figure and then calculate the answer. All right? Let me see what you get for your answer. All right, so I'm seeing some answers here, right? Just look at this, right? Look at what's happening here. So the question says round each number, right, to one significant figure and then estimate the value. Now, if we want to round this up to one significant figure, right, the 103, if I round that to one significant figure, is going to be 100. So this here is the square root of 100, right, divided by, now you have 81.25 and you want to round that to one significant figure. If I want to round that to one significant figure, that's going to be 80, right, minus, and you're going to round 32.41 to one significant figure, So this here is going to be 30, right? So what the question is asking here, or what I'm asking here, is that you know how to round to a certain number of significant figures. So the square root of 100 is going to be 10, right? And 80 minus 30 is going to give me 50. So this exact value here is going to be 1/5, right? Or you can give your answer as 0.2, right? So I know the question may seem simple, right? But you have to pay attention to what you're doing here, right? Take your time, go through the questions carefully, right? Go through the questions carefully. The next one here, so that's part A. The next one, we have 2 3/5 divided by 7/8 plus 3/4. Whenever you have a question like this involving fractions, what you need to do, you should work this bracket out first, right, before performing the division. So if you were to work this out here, that's 7/8 plus 3/4. So this is the same as saying 7/8 plus, now 3/4, you can make the denominator 8 here, right, by multiplying top and bottom by 2. So 3/4 is actually the same as 6/8. So when I add this here, right, you have the same denominator. So this is going to be 13/8. So that is what the bracket is going to give me. So I want to take 2 3/5. So 2 3/5, you're going to write that as an improper fraction. So 2 5s are 10 and 3 is 13. So this is 13/5 divided by 13/8. So therefore, this is the same as saying 13/5, right, multiplied by 8/13, right? So what's going to happen here is that this 13 will cancel with this, right? Now you can use a calculator for this question, and you're going to end up with 8/5 as your answer, right? Or you can write this as, this is going to be 1 3/5, right? So don't underestimate some of these questions, right? They require some thinking, right? Right, so that's question 1, part B. Let's see what else we have here. Right, so it just so happened that I pulled this question here, but this question is kind of similar to what we did yesterday as well. Emily is paid a basic hourly wage of $15 per hour. A basic work week is 40 hours. Overtime is paid at a rate of time and a half the basic wage, right? Calculate her basic weekly wage. So for part one is going to be rather simple, right? So her weekly wage, right? In this case here, it's going to be 40 hours, right? And you're going to multiply that by $15. And you're going to get $600, right? So that's a basic weekly wage, $600, right? So that part is straightforward. That's the answer for part 1. In the 3rd week of June, she worked a total of 50 hours. Calculate her total wage for that week, right? Now, when I set my questions, I try to make them not ambiguous like how CSEC does sometimes. I'm asking for the total wage here, right? Now, if she works 50 hours for the week, so this is the total amount of hours that she's working for the week. So we know that in a normal work week, it's 40 hours. Now, we already worked out the wage that she's going to get if she just works 40 hours. That's $600, right? So therefore, we have 10 hours overtime, right? It's 10 hours overtime. So we need to figure out how much money does that correspond to. Now, the thing is, you are working, overtime is paid at time and a half. So like I said yesterday, overtime is paid based on time and a half, double time, or triple time, right? So if it's time and a half, it's going to be 1.5 multiplied by $15. So that's going to give you your rate for overtime. So that's going to be 1.5 multiplied by 15. That's going to give you $22.50. So this here is $22.50, right? So that's the overtime here. So in this case, you work 10 hours overtime. So it's going to be 10 hours multiplied by 2250, right? Which is going to give us $225, right? So her total, that's what I asked for here. I asked for the total wage. So the total, right, is simply going to be the 600, which is a basic wage, plus the overtime, right, which is 225, and that's going to give us 825, right? Hope that makes sense. All right, so 825, right? People saying that making sense. Great, right? Now, the next part here, right? In the 4th week of June, she's paid $735, and we want to calculate what is, or how many overtime hours did she work for, right? Let's let me get a blank slide here. One sec. Now, when you get exam questions, try not to get flustered. Read the questions carefully, right? Read the questions carefully. All of the information will typically be there. So she's paid $735, and we want to calculate the overtime hours. So, simple diagram. This is how I typically do it in my classes. So we have $735. That's a wage, but that includes overtime. So we know that in terms of her payment, we're going to have a basic component inside there, which is $600. Right? So this is a basic here. That's $600. So that means that she actually had an overtime of 735 minus 600. So you're going to have $135. So this here represents her overtime hours, overtime wage. So if you want to work out number of hours, right, the number of hours is simply going to be $135, right? And you're going to take that and you're going to divide that by the overtime hourly wage rate, which is this figure here, $22.50, right? So you're going to divide this by 2250, and this here is going to give you your number of overtime hours. So this is going to be 135 divided by 2250, and you're going to get 6 hours. Right? So that's the number of hours overtime that she worked there, which is 6, right? Right? So some people got the answer. Excellent job, guys, right? Excellent job. So that's question 1, right? So typically question 1 is about 9 marks or something like that, right? Now, question 2, like I said, is usually our algebra question, right? Sometimes the questions are straightforward, sometimes they're a little tricky. So the first part here, we want to simplify this. We have y to the power 5 multiplied by y to the power 7. So we're going to have to apply our indices rules here. So this rule, once we have the same base, you're going to add your indices. So this is going to be y to the power 5, y to the power 5 plus 7. So this is going to give you y to the power 12, right? So that's one of our indices rules that we use in there, right? Next one here, we have to expand this, right, or simplify this. Again, this is another rule that we're going to use here, right? And if you all remember the rule is this: a to the power m, when it's raised to the power n, is given by a to the power m multiplied by n. So in this case here, it is going to be x to the power 3 multiplied by 2. So this is going to be x to the power 6, right? So that's the answer for this. That's why it's only 1 mark. It's very straightforward. You're using basic knowledge that we already have, right? Now the next part B, we have to factorize some things here, right? Now let me I need a blank slide again. So we want to factorize 12x squared plus 4x. Right? That's what we want to factorize. 12x squared plus 4x. Now, in this case here, right, we can factor using the HCF method. So what you would do, you would look at the 12 and you look at the 4, and the HCF of 12 and 4, that's the highest number that can go into both of them, is going to be 4. So I'm going to factor out 4. When I look at the x squared and I look at the x, the highest value of x that I can pull out in this case is going to be x, open brackets. So what you have to ask yourself now, 4x multiplied by what is going to give you 12x? So if you want to get back the 12x, this has to be a 3 and this has to be an x. Put back your plus sign, and you want to get 4x, so therefore this has to be 1, right? So this is going to be 4x, open brackets, 3x plus 1. So that's how we're going to factorize this one here, right? So that's the answer for this part here. The next part, we have to factorize a quadratic, and generally students have difficulties factorizing a quadratic. So I have 6x squared minus 7x minus 3. Right? Now, some students, they can look at this and they can factorize it just by looking at it. Some students, they have difficulties, right? So what I'm going to do here, I'm going to factorize this using inspection, right? So if we look at this last term here, right, that's minus 3. The only way I can get a 3 is if I have a 1 and a 3 here. That's the only way I'm going to get at, right? Now, I want to get 6x squared. There are multiple ways I can get 6x squared. I can take 6x by x. I can take 3x and multiply it by 2x, right? So in this case here, let's do a trial and error. Let's say 3x and maybe 2x, right? And let's see if we can factorize this. Now 3x by 2x will give me 6x squared. 1 by 3 will give me 3. Now we have to look at this middle term here. You want to get negative 7, right? So if I put maybe a plus here and a minus here, let's see if that works out for us. Right? So we already know that 3x multiplied by 2x is going to give me 6x squared, right? If I take 1 by minus 3, I'm going to get minus 3, so we're good. Now in terms of the middle term, in order to get this minus 7, you have to multiply these two. That'll give me 2x. And to get the... So this will give me 2x here, right? If I take 3x and I multiply by minus 3, I'm going to get minus 9x, right? So 2 plus minus 9 will be minus 7. So this is correct. This factorizing here is actually correct for this question. Right, so let's see. Right, so that's part 1 and part 2 here, right? So we just factorize these two here, right? Hence, we want to simplify this piece here now, right? Let me just snip something here. Hold on. Now, this is what we want to simplify, right? We want to simplify this. Now, what we're going to do, we're going to make use of some of the information that we already, or some of the things we already worked out. So 12x plus 4x, right? When you factorized it, you got this. So you're going to put 4x, open brackets, 3x plus 1, right, all over, and when we factorize the 6x squared minus 7x minus 3, this would have been 3x plus 1 by 2x minus 3, right? So in this case here, if you notice something here, some things will cancel. So this here will cancel with this. So therefore, the final answer, right, the final answer is going to be 4x all over 2x minus 3, right? Right? I know some people were wondering the paper that I did last night. They found it a bit too easy, right? So I brought one of my own exams here, right? All right, now, sometimes you can get a question that looks a little scary like this, right? We can get a question that looks a bit scary like this. So the diagram shows two rectangles not drawn to scale, right? And the total area of this shape is 39 centimeters squared. And we want to show that this is true here. Anytime you get a question in the exam that says show, that's a question that you already know the answer to. So you should focus on getting it correct, right? So you're trying to show something here. Now, what I will do in a scenario like this. So I will tend to, you know, the area of the entire shape is 39. So what I will do, I will break it up into two parts. I will call this A1, that area A1. I will call this area A2. Right? Now, that means that I have two rectangles, two potential rectangles here, right? Now, I know this length and I know this length. So I can multiply those two and figure out what is the area A2. In terms of A1, you have this length here, but you don't know what this length is here. You need to figure that out, right? So if you want to figure out that length, all you do, you take this 3x here, right? And we're going to subtract this. Right? So that length that we're trying to work out here, let's call that L. I don't know what it is, so I need to figure that out. So this is going to be, you're going to take the longer side, which is 3x, and you're going to minus the short side, which is 2x minus 1, right? Now, some students, like I said, they have trouble with this. Now, because we have a minus sign in front of a bracket, this is actually 3x minus 2x, right? Plus 1, right? So therefore 3x minus 2x, that's going to give you x, and we have x plus 1. So this length here is actually x plus 1. That's what this length is, right? So now technically I have all the sides in order for me to calculate this area. Now this thing here is going to be a bit tricky, and you have to be very strong in algebra to be able to simplify this thing. So let me just get a blank page and let's do it on a blank page. Right? Now, what we know based on the question, we know that when I add up the two areas, I should get 39 centimeters squared. Right? That's what I know. So I'm going to write A1 plus A2. Right? I'm going to get 39 as my answer, right? Now the area A1, to work out A1, you have to take this length and multiply by this length. So that's x plus 2 multiplied by x plus 1. So this is going to be x plus 2 multiplied by x plus 1, right? So that's the area A1. The area A2 now, you're going to have to take this length, 2x minus 1, and you're going to multiply that by 5x minus 1, right? So this is 5x minus 1, and you're multiplying that by 2x minus 1. Right? And you're going to get 39. Right? So now, what we're going to do, we're going to simplify this, and we know what the answer is supposed to be. The answer is supposed to be this. Right? So that's what we're working towards. Now, for you guys who can't remember how to remove a bracket, I'm going to just put in my arrows. I like to put in my arrows one time. So you're going to take this term, multiply by this term. You're going to take this, multiply by this by this, and this by this. So I'm just going to put in the arrows, and then I'm going to multiply it out. To remove this bracket here, it's going to be this by this, then this by this by this, and then this by this, right? Write the arrows if you need to in the exam, right? It's going to help you in the exam, right? Right? I don't want anybody wasting time in this live session, right? So anybody who's basically saying a set of nonsense, I'm going to just kick you off, right? Right, so let me go try simplifying this thing. So x by x, you're going to get x squared. Then we have x by 1, so you're going to get x, right? Then 2 by x will give me 2x, right? Then 2 by 1, you're going to get 2. Now take your time, don't rush these particular questions. It's very easy to make a mistake, right? It's very easy to make a mistake, right? So that's the first set of brackets, plus, then we have 5x by 2x, that's going to give me 10x squared, right? Then we have 5x by minus x, this is going to be minus 5x. Then we have minus 1 by 2x, you're going to get minus 2x. Right? And then we have minus 1 by minus 1. This is going to give me plus 1. And that is equal to 39. Right? Now, you have a big long expression here that you're trying to simplify. Right? Now, let's go back to see what the answer is. Let's make sure we're on the right part. Okay. Kind of looking okay so far. So, all I'm going to do, I'm going to bring all my like terms together. So, I'm going to say x squared plus 10x squared. Right? Plus x plus 2x, right? What else we have here? We have minus 5x, right? We have minus 2x. Then we have 2. We have plus 1. And then I'm going to bring across the 39 on this side one time, right? So now 10x squared plus 10x squared is going to give you 11x squared, right? 1 plus 2 is 3. Right? 3 minus 5. Yeah, 3 minus 5 is going to be minus 2. And minus 2 minus 2, you're going to get minus 4x. So this is going to be minus 4x. Right? And then we have 2 and 1, 3. 3 minus 39 is going to give you minus 36. Right? Is equal to 0. Which is what they asked us to prove. Right? If you notice here, this here is what they ask us to prove. So you have to take your time and simplify this thing until you're able to get this. Right? Right? Yeah, so I know this question is a little tricky, but these are the kinds of questions that actually come in the exam. Right? So this is that was question 2, right? Third question. So your third question is normally on geometry and transformations. So the following diagram shows 3 polygons, A, B, and C. B and C are images of A after undergoing 2 separate transformations. So you could be given a diagram where we have some objects and there is some form of transformation taking place here. One second. So the original, right? So this is your original shape here, right? A is your original shape, and B and C are the images after A is transformed. Now let's see what I want here. So on the diagram, draw the image of A after. So 2 things we're going to do here now. So we want to draw a translation of this thing here using the vector minus 6 minus 2, right? So the vector is minus 6 minus 2. Now, you guys need to understand what those numbers mean, right? Minus 6, in this case here, means you're going to move 6 units, right? Left. That's what that means. And this minus 2 here means 2 units down, right? So these numbers mean something to us, right? So negative 6 means that you're going to move 6 units to the left and you're going to move 2 units downwards, right? So what I will do, right, you don't have to translate every single point. So let's say I start with this point here, right? And you want to move 6 units to the left. So you're going to go 1, 2, 3, 4, 5, 6. So this is where this is going to be here. And then you're going to move 2 units down. So we're going to go 1, 2. So this here is the final position, right? That's the final position here. One sec. Let's erase this, right? So that's the final position there. Now you don't need to go and draw or do that for every single point, right? Since you know what that point is, you can actually go ahead and you can draw what the shape is going to look like. Now, I'm drawing it freehand here, but you can use a ruler in order to do this, right? So this here represents my translated shape here, right? And they said to label this A prime. So this here is my A prime, right? So it's minus 6 units to the left, right? Or 6 units to the left. And then we have 2 units downwards, right? Right, so that's my E prime. Now, last night I told you guys that what they do, they try to bring all the transformations in one question. So that's, and they consider that easy, so that's about 1 mark. Next thing we want to do, we want to reflect in the line y is equal to 0. Could you all tell me what's the line y is equal to 0? What line they're talking about there? What is the line y is equal to 0? What is the line x is equal to 0? Alright, so I've seen people telling me it's the y-axis, or at least most people saying that, right? Now you have to be careful here, guys. You see your x is equal to 0. This here is actually your y-axis, right? This is your y-axis. X is equal to 0 is your y-axis. So what you're going to do, you're going to do a reflection in the y-axis. So let's go back here now. I'm going to use a different color for this one, right? So remember, this is your starting object here and you want to reflect it, right? So therefore, if I reflect this, right? Now you can do this just by looking at it. So this here, right? 1, 2, 3. Now please use a ruler when doing this. I'm just drawing it freehand here because I'm kind of doing it fast, right? So that is your A double prime. It's a reflection in your y-axis. Once you're reflecting in the y-axis, think of if you fold the paper along the y-axis, your object and your image needs to line up exactly, right? So that's correct. That's the answer there. Now, some students lose marks for these questions here now. Describe fully the transformation that maps A onto B. What you all think that transformation is here, right? What is A mapped onto B, right? What transformation is that? Right. So a lot of people saying it's an enlargement. I agree it's an enlargement, but I want you to pay attention to something here, right? I want you to pay attention. You notice this is 3 marks here, right? So if you set enlargement alone, you're actually only going to get 1 out of those 3 marks, right? So here's what you have to do. When it comes to an enlargement, there are several things that we need to see. So here's what you need to do. You're going to take your ruler, right? So I'm just going to draw some lines here. Right? So all I'm doing, I'm joining, and you don't need to do it for every single point, right? So let's say I join maybe this and this. Right? Now what I suggest you do is do it for 3 lines. Just draw 3 lines, and wherever those 3 lines intersect, that's going to give you some information that is important, right? So you're going to take your ruler to do this, by the way. So if you notice, I've drawn 3 lines here. Now you notice that that B is actually larger than A, so we know it's an enlargement. But there are certain things we need to see. So when it comes to an enlargement, we need to specify the center of enlargement, and we need to specify the scale factor. If you notice, all of those 3 lines, they pass through the point 0, 10, right? Now you have to be careful. Some students will call that point 10, 0, but it's 0, 10. So that's your center of enlargement. And we need to also specify what's the scale factor. To get the scale factor, all we need to do is to look at one of the lengths here. So let's say this is 1 unit here. But if you look at the enlarged image, this is 2 units. So clearly the scale factor is 2, right? If you look, the length is doubled. That is 1, and this here is 2. So therefore the scale factor is 2. So in order to get those 3 marks, there are several things we have to say. So you must specify enlargement. Right? So again, 1 mark for that. We need to say the center of enlargement. Right? And that point was 0, what it was, 10? 0, 10. Let's go back here. Yeah, 0, 10. And you also must specify the scale factor. So the scale factor, right, scale factor K is equal to 2. So you're doubling the linear dimensions of your object, right? You have to say all of that in order to get the marks, yeah? Right. So next part now, we want to, right, so that's part 1. Part 2 now, we want to know what maps A onto C. So let's go back to the diagram here now. So remember, the original object is A, and you want to go to C. That's across here. What you all think that is? What does that look like to you? If you look at A and C, what transformation maps A onto C? Right, so some people saying it's a rotation. Yeah, once you see there's a change in the orientation of your object, it's a rotation, right? Now, what you have to do when it comes to rotation, so if you notice again, watch this. It's 3 marks again, right? So you all said rotation. Yep, rotation is correct. But when it comes to rotation, we have to specify the center of rotation. right? We need to specify the center of rotation, and we must also specify the angle and whether it's clockwise or anti-clockwise. Now, if you look at the diagram, and this here, you're going to have to use your compass in order to figure this out, right? In this case here, the center of rotation, let's see, yeah, the center of rotation is actually this point here, right? So if I were to take the shape A, and I were to rotate it so that this point here is now here, what you're actually doing, you're rotating this way by 90 degrees, right? So this center of rotation here is actually minus 1,5. So center of rotation is minus 1,5, right? And we're moving, based on what we see in here, you're moving 90 degrees anti-clockwise. So you need to say that. You need to say 90 degrees anti-clockwise. This is all the things that we need to say in order to get the marks, right? Pay attention to the marks. That's usually a guide when it comes to answering some of these questions, right? So that's our third question. Right, so let's move on to question 4, right? So question 4, right? The diagram shows two lines. So we have L, M, and we have L and we have M, right? Two straight lines. Let's see what we want to do here. Write down the coordinates of the x-intercept of L, right? Could you all put that in the chat for me? What are the coordinates of the x-intercept of this line here, L? What are the coordinates of the x-intercept of this line here, L? What are the x coordinates of that line L? Right? Some of you are having some trouble with this, right? Most people have it correct. So the x-intercept is where do I cut my x-axis? It's cutting here. So that coordinate is actually 8, 0. You always write down your x coordinate first. So the answer for this part here is going to be 8, 0. That's the x coordinate here, right? Sorry, the x-intercept, right? What about this second part here? What is the y-intercept of line M? So this is line M here. I want to know what are the coordinates of the y-intercept. Right, so let's see what's happening here. So a lot of people seem to have a little confusion here. If you want to get the y-intercept of the line M, right? So the line M is cutting at this point here. So therefore, that coordinate is going to be 0, 1. That's the coordinate here, right? 0, 1 is going to be the answer. So this here is going to be 0, 1, right? You don't want to get something like this wrong in the exam. It is too simple. All they're trying to ask you is where does the graph cut the y-axis, right? That's called your y-intercept. That's what they're looking for. Right, now that takes care of part A. Now part B now. The equation of the line L, right? So they gave us the equation of line L. Find the value of P given that the point P lies on that line. Now, the equation of this line here, so this is part B, right? The equation is given by x plus 2y is equal to 8, right? and this point here lies on that line. So that's a coordinate they're giving us here. So what they're trying to tell us here is that x is equal to -6 and y is equal to p. That's what they're telling us here, you know, right? So if you want to figure out what p is, all you need to do is to plug that into this equation here. So this is going to be -6 plus 2y, in this case y is going to be p, is equal to 8. So 2p is equal to 8 plus 6. So 2p is equal to 14. So therefore p is equal to 14 over 2. So therefore p is equal to 7. Right? That's the value of p here. Right? So that takes care of part B. Part C now, we want to work out the equation of the line M. So you want to work out the equation of the line M. Where is M? Right? So let me just erase some things here. So this is M, right? Now remember, the equation of a straight line is given of the form y is equal to mx plus c, right? Now c is your y-intercept, but if you notice something here, we already know what c is. C is actually 1, right? That's the equation, that's the value for c. C is actually 1. We know this already. So all I need to do, I need to figure out what is the gradient of that line, right? So what I'm testing here, I'm trying to see if you know how to calculate the gradient of a line, right? Now to calculate the gradient of a line, all you need 2 points on the line in order to do that. So this is 1 point, 0, 1, and I can choose another point that is easily read off from the graph. So I'll probably choose a point like this, which is 3, 7, right? And I'm going to use those 2 coordinates in order to work out the gradient of this line here. So I need a blank slide. Hold on. Right, so the 2 points that I have on the line, I have 0, 1 and 3, 7. So I have 0, 1 and 3, 7. Right, and we already know that the y-intercept is equal to 1. Right, and the general form of any straight line is y is equal to mx plus c. Now here's what I normally tell my students to do. Always label these things, right? So this here, I'm going to call that x1. I'm going to call that y1. Right? I'm going to call this x2. And I'm going to call that y2. Why am I labeling that? Because there's a formula to calculate gradient. So your gradient is given by this formula here. Y2 minus y1 all over x2 minus x1. All right? So once I label the coordinates, it's just a matter of substituting. So this is going to be 7 minus 1 all over 3 minus 0. Right? So 7 minus 1 is going to give me 6 divided by 3. So this is going to be 2. So therefore the gradient of that line M is going to be 2. So therefore the equation, right, of M, right, is going to be y is equal to 2x plus 1. Right? That's the answer for that part there. 2x plus 1. Now let's see what else we have to do. Next thing we have to do, we have to prove that L and M are perpendicular. Right? We have to prove that L and M are perpendicular. Now the thing is, you know what the equation of L was. It's x plus 2y is equal to 8. So this is L. And the equation is x plus 2y is equal to 8. Right? Now what I need to do, I need to figure out what is the gradient of L. So therefore, anytime they ask us about gradient, you have to write it in this format first. So in this case here, it's going to be 2y is equal to minus x plus 8. So then y is equal to minus a half x, right? Plus 8 divided by 2 is going to give you 4. Now, what you all need to remember is that when you are trying to prove that two lines are perpendicular, what happens is that when I multiply the gradient of one line by the gradient of the second line, I should get minus 1. That's one of our rules for geometry here. If I multiply the gradients of two lines, I'm going to get negative 1, right? So watch what's happening here. So the gradient of m is 2, and the gradient of this one here is a half. So therefore, if I take 2 and I multiply that by negative a half, right, I'm going to get negative 1. So this is how you prove that. You need to show that when you multiply the two gradients, you're going to get negative 1. That's what you're trying to do. Right, the stream has been recorded, guys, so anything you miss, you could still go back to it, right? But these are the types of questions that you get in your current paper 2 exam, right? What else we have to work out here? I think we have one more part. Yeah, we have one more part to the question, right? And the question is this. L and M represents two simultaneous equations. Use the graph to determine the solution to the pair of simultaneous equations. Right? So L and M represents two simultaneous equations. That's what they're telling us, right? And they want to know, based on the graph, what are the solutions to that pair of simultaneous equations. You all feel you could give me the two values, the x and y values from this graph? Right, I'm now looking at the questions here, right? So C, guys, C is not always 1, right? It depends on where the graph cuts the y-axis. Right, could you give me the two solutions here? Anybody can give me that? What are the two solutions if those two lines represents a pair of simultaneous equations? What is the solution to that pair of simultaneous equation? I wonder if anybody knows how to work this out. Somebody, okay, a few people answering the question, right? Here's what you all need to do here, right? Here's what you need to do. Whenever you are asked to solve a simultaneous equation graphically, what you're really doing is you're trying to figure out where do the two lines intersect, right? So therefore, all you need to do is to figure out the coordinates of this here, right? And I saw some people get it correct. So the x coordinate is actually 1.2 according to the graph, right? And the y coordinate there is going to be 3.4, right? So it's 1.2 and 3.4. So those of you who said that, yep. 1.2, 3.4. So there's no, you don't have to go and do elimination or substitution. This is solving a simultaneous equation graphically. All you're doing is figuring out where does it cut your, where the two lines cut. That's what you're trying to do, right? So that takes care of question 4, guys, right? Now I'm moving on because I want to complete the entire paper if I can, right? Question 5. So this question here, question 5 in your exam, is based on statistics. So the average time taken for 200 students to travel to school was recorded and a cumulative frequency curve was drawn. So I have a cumulative frequency curve here. You have cumulative frequency and you have time in minutes taken for these students to arrive at school. You have 200 of them, right? Now let's see what questions I have here. Using the cumulative frequency curve, estimate the number of students who took more than 40 minutes to travel to school. Let me see if anybody could figure this out. I want you all to use my graph to figure out the number of students who took more. So number of students who took more than 40 minutes. Right? I want you all to look at the graph and let me see if you can come up with an answer here. Right? Some of you all in the previous question there, it depends on how you read off the graph, right? So some of you all saying you got 3.3, right? It'll be an estimate. So 3.3, 3.4, 3.2, right? So some of you all kind of know what to do for this part. So here's what's happening here. You want to work out how many students took more than 40 minutes. So what I would do, I would take my ruler, right? In this case here, I'm just going to pull right? So what you'll have to do, you have to take your ruler. You're going to come by 40 here, right? And you're going to read off this value here. That's what you're going to do. Right? Right. So when I read this off, listen, that line is so bent. Right. So we have this here, right? But I need to read off that value on my y-axis. Right? So we're going to come down here, right? And you're going to read off this value here. Now, when I read this off here, now some students have trouble reading this off. So let me tell you something one time. You need to figure out what each small line represents on your y-axis. Now, this goes from 0 to 20, but you have 5 spaces. So therefore, if you want to figure out what each small line is, you're going to take 20 and you're going to divide by 5. So that means that every small line represents 4. So if I were to read this off here, that's 144, 148, 152, 156. So this reading here is actually 156. That's how many students. But a cumulative frequency curve always gives us less than, right? So when you see a question asking you for more than, you have to be very careful. So the answer, what you need to do, you got 156, right? So you're going to have to take 200 minus 156, right? And that's going to give you how much? Right? So you're going to get about 44, right? Now remember, this here is, it's going to vary depending on how you read it off, right? Is that making sense? Right? right? So be careful. If you get a cumulative frequency curve and they're asking you for more than, you need to be careful, right? Right, so that's the answer for that part there, right? It's an estimate, right? It's an estimate, so you're gonna have to kind of look at it carefully, and then from there you can make an estimate, right? Because I saw some people got 42. It could be 42 depending on how you read it off, right? So that takes care of this part here. They want you to work out the median time to travel to school, right? So what you all think the median is here? What do you all think the median is here? What's the median time to get to school according to this graph? Alright, so I've seen some people saying 34, 35 minutes. Yeah, in these questions here, it's an estimate, right? When they ask you for the median, you need to look at your highest cumulative frequency. So that's 200. So you're going to divide that by 2. So what you're going to do, you're going to go to the graph and you're going to read off at 100, right? So when I come here, right, I'm going to read off that value there, right? But you're reading off that value on your time axis. So therefore, look at where we're reading off here. You're reading off at this point here, which is about 35 minutes. It's midway between 30 and 40, so that's 35 minutes. A common mistake would be for students to say 100 is the answer, right? But you have to take 200 divided by 2, you get 100, and then you have to read it off from your graph, right? So it's 35 minutes. Right? So that's my median here. So that's part 2. The next part, we want to work out the probability that a student selected at random took at most 25 minutes to travel to school. Now, this word in here is something that you have to be careful with. Whenever you are asked, when they say at most 25, that really means less than or equal to. That's what this means, eh? Less than, right? Or equal to 25 minutes, right? Less than or equal to 25 minutes. So to work that part out, all you're going to do, you're going to go to the graph, right? You're going to go to the graph and we're going to read off where 25 minutes is, right? Right, approximately here, right? And then what we're going to do, we have to read off here. Right, so according to mine, it kind of looking like this, right? So it kind of looking like around here. Make sure. That's about 38, right? When you read this off here, this is about 38, right? Based on what I'm seeing here, right? But like I said, when it comes to a question like this, you have to kind of estimate. Some students might have slightly different answers. So the probability, all right, the probability for this third part here is simply going to be 38 students, right, divided by the total number of students, which is 200. So you can leave your answer as a fraction if you want, or you can put it as a decimal. It doesn't matter, right? CSEC will accept either of them, right? Make sure you walk with a calculator for sure tomorrow, right? Walk with a long ruler, right? Walk with a geometry set, right? Make sure you have pencils, sharpener, eraser, right? All of those things are required, right? right? It's a different paper, right? That's a common question I get. The January exam is different from the June exam, people. Right, now we have a next part to this question here now, right? Using the cumulative frequency curve, we want to complete this table here. Now, lots of students have serious problems with questions like this, right? They have serious problems with questions like this, and CSEC have brought this question at least twice in the past few years, right? So you want to complete this table. So what has happened here is that they gave us a cumulative frequency curve, and what they've done, they've given us what the frequency looks like, right? Now, what we need to do, we need to go to the table, go to the graph, sorry. So if you notice, the frequency here, the first frequency is 4. And when it comes to cumulative frequency, what we actually use to plot these things, we use our upper class boundary, right? So this one here, the upper class boundary is 10.5. This one will be 20.5. This one will be 30.5. This one here is 40.5. Next one is 50.5. And the next one is 60.5. So some of you all might be wondering, well, why do I need that? Right? You see, in these questions here, you're working backwards. You know what the cumulative frequency curve looks like, and you're trying to come up with a table, right? So if we look at something here, our boundary, the first boundary is 10.5, right? That's the first boundary here, upper class boundary. When you go to the graph and you try to read off where is 10.5, you will notice that this value here is actually 4. So that's where this 4 came from here. That's where that 4 came from. What we're going to do now, we're going to read off at 20.5. When you read off at 20.5, according to this graph here, right, 20.5, that corresponds to maybe about 24. So 20.5, if you look at the graph here, that corresponds to about 24. So if that is 24, that's a cumulative frequency. That means that this frequency here has to actually be 20. That's what that frequency is here, right? So you had to read off this value from the graph. You got 24, right? That's a cumulative frequency. And what we need to do to get the frequency, you're going to take 24 and you have to subtract this, right? So that answer here is going to be 20. Now, they already filled out this for us. They filled out this for us here. So we have one that is missing, right? So what I'm going to do, I need to read off at 50.5, right? I need to read off at 50.5. So in this case here, when I read off 50.5, let's go back to the graph. So 50.5 is around, that's going to be about 182, right? This corresponds to 182. Now, in order for me to get this frequency here, right, I need to remove everything that I had before, right? So 182, I have to subtract all of this here, right? Now let me just double check something here. So that's 24 plus 36 plus 100, right? I'm gonna get, right. So when you add up all of these here, right? All of these frequencies here, you're gonna get 160, right? But the cumulative frequency is 182. So therefore, to get what frequency I'm gonna put here, it's gonna be 182 minus 160, right? And that's gonna give me 22. So this here is gonna be a frequency of 22. Now this is one of those tricky questions, right? This is one of those tricky questions. right? So we haven't completed the table as yet, right? So if you notice, we have midpoint, right? So this is group data we're dealing with now. So we have midpoint and we have frequency multiplied by midpoint here. So all we're doing to complete the table, we have to take 20 and multiply by 5.5. You're going to get 15.5, sorry, multiplied by 20. You're going to get 310, right? The next one here will be 45.5 multiplied by 22. And you're going to get 1001, right? So this is your completed table here, right? That's your completed table. The last part of the question, we want to use this information to estimate the mean time taken for students to travel to school, right? So all we need to do to get mean, your mean is given by sigma xf over sigma f. So in this case here, all we need to do, we need to add up this column, and we know the frequency column should add up to 200. This here should add up to 200. So all I need to do is to add up the xf column. So this is 200 here, all right? So that's going to be 22 plus 310 plus 918 plus 3550 right? I'm getting 6800 divided by 200, and I'm getting a mean value of 34 minutes, right? Now you must know if your answer is wrong, right? Because your median and your mean should be around the same value. So if you notice something here, when we estimated the mean from the graph, we got 35 minutes. Sorry, the median from the graph is 35 minutes. And when we calculate the mean, you notice we get in around 34 minutes. So the numbers are pretty close, right? The numbers are pretty close. Right? So that's our statistics question, right? Question 6 is going to be your measurement question in the exam. Question 6 is always measurement. So in this question, we're going to take pi as 22 over 7, and they are giving us the formula for the volume of a sphere, right? So the diagram shows a sphere of radius r fitting exactly inside a cylinder of height 14 centimeters, and the base diameter is also 14 centimeters. Now, the first part of the question here, state the radius of the sphere, right? Now, since the sphere fits exactly in the cylinder, and this here is 14 cm, right? The radius of the sphere has to be 14 divided by 2. So therefore, this here is 7 centimeters, right? That's the answer for that part. The next part, we want to calculate the volume of the cylinder, right? Now, you guys need to know your formulas for the volume of a cylinder. That is not given to you in the exam. So the volume of a cylinder is given by pi r squared h. That's the formula. So in this case, it told us to take pi as 22 over 7. So it's 22 over 7 multiplied by the radius squared. So that's going to be 7 squared multiplied by the height, which is 14, right? So when you work this out, you're going to get 22 over 7 multiplied by 14, right? And you're going to get 2156, right? And this is volume, so that is cm cube. So that's the answer for the volume of the cylinder, right? So guys, the only formula you need to remember is the one for the cylinder, right? If they give us a sphere in the exam, they're going to give you they're going to give you the formula for that volume. So you don't need to learn up that. Just make sure you know the 1 pi r squared each, right? Make sure you know that one. Right? So that's the volume there. We need to calculate the volume of the sphere now, right? That's the ball on the inside. So they gave us the formula. It is 4/3, right? Pi r cube. So in this case here, it'll be 4/3 multiplied by 22/7 multiplied by the radius cube. The radius in this case here we know was 7. So this is 7 cube over 1. When I work this out, I'm going to get right, and what I'm getting here, according to my calculator, I'm getting 1437 and 1/3 cm cube, right? That's what I'm getting here. So that's the volume of this sphere, right? All I did was use the formula, right? And the last part, calculate the percentage of the cylinder occupied by the sphere, right? So the percentage occupied, right, is simply going to be, so the volume of the sphere was 1437 and 1/3, right? And you're going to divide that by 2156 multiplied by 100%, right? Because you want to know the percentage that is occupied by the sphere. So in this case here, when I divide this by 2156, I'm going to get 2/3 by 100. So you're going to get 66 and 2/3%. Right? So that's the volume that is occupied by the sphere here. Right, so that's part A of the question, right? Part B here, so this, see these kinds of questions, these questions are also tricky. So we have a scale, right? The scale is 1 to 500,000, right? So the actual distance between Aberdeen and Braden is 30 kilometers, right? Calculate the distance between, that's all, let me change this here a little bit. Just give me 1 sec here, right? I'll typo in that question there. Right, so let's have a look at this here, right? Right, so when you have a scale question like this, right, that scale is telling us something here. Now, I don't like to learn off any formulas. So if the scale is telling me 1 to 500,000, right, that means that 1 cm on the map actually represents 500,000 cm, right? Now, there are some students who they like to learn off these things, and that's okay if you want to do that, right? But what I'm going to do, I'm going to say, okay, 1 cm, right, actually represents, so this 500,000, I'm going to convert that into meters first of all. So if I convert this into meters, I'm going to divide by 100. If I divide by 100, I'm going to get this, 5,000 meters. So to jump from this to this, you're going to divide by 100, right? When you want to convert from centimeters to meters. Now, I need to convert that into kilometers. So if you want to convert from meters to kilometers, you're going to divide by 1,000. So therefore, this here is going to give you 5 kilometers. So to jump from this to this, you're going to divide by 1,000, right? Now, why do I need this? This here is going to help me work out the entire question. 1 cm actually represents 5 kilometers. That is what I'm going to use to solve this entire question here. So, how am I going to do that? So the distance between San Fernando and Sangre Grande is 30 kilometers, right? Now my scale here is this. So I know that 5 kilometers in actuality is represented by 1 cm, right? So if I want to work out for 30 kilometers, right? Then all I'm going to do, I'm going to say 30 kilometers. I'm going to take this number, multiplied by this number here, and divide by this. So this is going to be 30 multiplied by 1 divided by 5. So therefore, on the map, that is actually 6 centimeters, right? So that is how you work a problem like that. You need to figure out how many kilometers do we have in 1 centimeter. That's how you're going to do a question like this, right? Right, so that's the answer for part 1. Part 2, well, this one is even worse because some students definitely have trouble working a question like this, right? Now let me show you how you're going to deal with a problem involving area, right? Area is one of those tricky things. Right, now we already know what the scale is, right? But when it comes to area, all you need to do, so on the map, right, if I'm going to draw a small square here, and that small square, I'm going to give it dimensions 1 cm by 1 cm, right? That's on the map, right? So on the map, this area here is going to be 1 cm squared. Now in actuality, right, it is going to be much larger. But we already learned, right, based on our calculation here, that 1 cm is actually equal to 5 kilometers. So therefore, when it comes to your dimensions here, this is actually 5 kilometers, and this here is also going to be 5 kilometers. So therefore, the area, the actual area, is going to be 5 multiplied by 5, which is going to be 25 kilometers squared, right? So what I know here is that 1 cm squared, right, is actually equivalent to 25 kilometers squared. That's what I know based on the area. Now, the question is asking me, if I have a field that is 2 cm squared, what is the actual area in kilometers squared? So all I need to do here, I already know that 1 cm is equal to 25. So if I want to get for 2 cm squared, right, it's simply going to be 2 multiplied by 25. So therefore, this is going to be 50 kilometers squared, right? This is one of those trouble areas for a lot of students, right? Right, I noticed some people asking about the June exams. Yeah, so this system is kind of crazy as far as I'm concerned, because if somebody writes the exam in January and you did not sign up for June and you fail in January, it means that you're gonna have to wait till 2025 to write the exam again, because registration for June that already passed. Right, so that takes care of question was this? Question 6, right? So question 7 in your exam, guys, it is going to be based on what we call an investigation type question, right? So question 7 is based on an investigation type question. So we have a pattern here. The diagram shows the first 3 figures in a sequence made up of identical regular polygons. We want to draw, right, what is figure 4 for 2 marks. Now if you notice what's happening here, when I jump from figure 1 to figure 2, I've added another one of this. When I jump from figure 2 to figure 3, I've added another one of this, right? Now I don't want to, hold on, I don't want to draw over this whole thing, but if I want to draw figure 4, right? Right, all I need to do is to add one more shape there. That's all I need to do, right? So this here is going to be figure 4, right? And we're going to add one more of this thing here. So we're going to go like this, we're going to go like this, this, and we're going to come down here. So that's your figure 4, right? That's your figure 4. And they want us to state the name of this polygon here. What's the name of that polygon? What do you all think that is? Yes, guys, we only did 6 questions. Your biggest enemy in that paper tomorrow is time, you know. Time is going to be a problem in that paper, right? Right, some people telling me it's an octagon. Yep. Right, yes, the shape is an octagon. It is an 8-sided figure, right? It's an octagon, right? That is correct. Now, so I recently did this with my Form 5 class. I showed them how to handle a question like this, right? So you have a table here, and we have figure, we have number of vertices, and we have number of lines. And we want to complete this table here, right? Now, if you notice something here, right? You have to try to see if there's a pattern here, right? When we go from 8 to 14, right, what you're doing, you're adding 6. When you jump from this to this here, you notice you're adding 6 again, right? Now, you want to work out for figure 4. So there are 2 ways we can do this. You can go back to the diagram itself and actually count the number of vertices if you want, right? Or, since you realize we add in 6, if I jump from here to here, I'm going to add 6 again, so I should get 26, right? Now, if we look at the number of lines, when I go from here to here, right, 8 to 15, I'm adding 7, right? And when I jump from here to here, I'm also adding 7, right? So in this case here, if I want to get what comes next, I'm going to add 7 again. So therefore, this here is going to be 29. So just like that, I've worked out something here already. Now what I normally tell my students to do, right? Try to work out the pattern or work out the rule for your end figure, right? Work out the rule for your end figure. Now, let me see. I know I have some of my students in class here right now. could you all tell me what's the rule or what's the equation for the number of vertices in terms of n? Let me see if I see some of my students know how to do this here. Aha, right? So I've seen some of my students here responding, right? Which means you all remembered how to handle a question like this. So a lot of people telling me 6n plus 2. Yep, that is the pattern rule. It is 6n plus 2, right? 6n plus 2. Now, what I told my class is that these numbers here, right? These numbers here have to appear. So these numbers here, this 6 here is being repeated. So that 6 here is going to appear in your formula, right? So that's where that 6 came from here. So that formula 6n plus 2 is going to hold up. What about the formula for the number of lines? What about this one here? What's that formula going to be? Right, somebody's asking how we got it 2. You have to plug in some of the numbers in your table. So you can plug in the 1 into your formula and make sure you get 8. Plug in 2 into the formula and make sure you get 14. Plug 3 into the formula and make sure you get 20. That's where that 2 came from. You have to figure that piece out. Alright, so people worked out the second part as well, right? Right, so some of you all trying to figure out how we got the 2, right? What you need to do, you have to come up with your formula. The first figure was figure 1 and the answer was 8. Since you know 6 has to be in the formula, it is going to be 6 multiplied by 1. And if you want to get 8, you have to add 2. That's where the 2 came from. I saw a lot of people telling me this formula is 7n plus 1, right? So based on what we said before, since the pattern is increasing by 7 all the time, right? That means that 7 is going to be in your formula. So some of you all might be asking how we got 1. So in this case here, the first figure is 1 here, but you're supposed to get 8 as the number of lines. So when I plug 1 into the formula, 7 by 1, in order for me to get 8, I need to still add 1 to it, right? So that's my formula there. 6n plus 2 and 7n plus 1, right? Now the thing is, with this particular question here, guys, this requires some practice, right? In order for you to be able to figure out these patterns. The next thing we need to work out here now, we need to complete the rest of the table, but we know the number of vertices here is 38. So all you need to do, you need to say 6n plus 2 is equal to 38. And what this is going to allow us to do is to figure out what is the figure number here. So this is going to be 6n is equal to 38 minus 2. So 6n is equal to 36. So n is equal to 36 over 6. So therefore, this corresponds to figure 6. So this here is going to be 6, right? So we almost finished with the table. To figure out this one here, we just need, since we know what n is 6. You're going to plug that into your formula. So that's 7 by 6 plus 1. So 7 6s are 42 plus 1, you're going to get 43, right? So that's my table. These tables, they typically like 10 marks on them, right? So that's the answer for question 7, right? Question 8, right? Question 8. So we have a function question here, right? And we want, so we have f, we have g, and we have h. And the first part, we want to work out g of x minus 2. So g of x is equal to 2x squared minus 3. And you want to work out g of x minus 2. So what am I doing here? All I'm doing here, I'm plugging x minus 2 into this formula. So it's going to be 2 by x minus 2 squared minus 3. Now, you have to be careful when you expand in this here. So this is going to be 2 When I expand x minus 2 squared, it's going to be x squared minus 4x plus 2 minus 3, right? When I remove the brackets, I'm going to get 2x squared minus 8x plus 4 minus 3. So this is going to be 2x squared minus 8x plus 1, right? So remember, the questions, they become a little more difficult coming on to the end of the paper, right? All right, let's make sure that's correct. 2x squared minus 8x. 2 2s are 4. All right, this one, hold on. I have a little error here. Right, this should have been a 4 here, right? This is a 4 and this is an 8, so therefore 8 minus 3 will give me 5, right? Right, that's all. You all said I missed out piece. Oh, yeah, my bad, right? Thanks for pointing that out. Some of you all said I missed out piece. That is true, right? I didn't see the 92 there, right? This one here, right? So all we're gonna do here to figure out this, so let me just do this quickly. You're gonna put 7n plus 1 is equal to 92. Right, so 7n is 92 minus 1, so 7n is equal to 91, so n is equal to 91 over 7, right? You're going to get 13, right? So therefore, this value here is going to be 13, so this one is going to be 6 by 13 plus 2. And you're going to get 80, right? So yeah, my bad, missed out the question. Right, so let's go back here now. So all I did, I worked out this piece here, right? So that's part 1. Part 2, we want to find f inverse of 15. Right, f inverse of 50. Now, the first thing we need to do, we need to find the inverse of this function here, right? We have 2x minus 1. You want to find the inverse of that function, right? So to do that, I'll get a blank slide for that. Right, so we have f of x is equal to 2x minus 1. Right, and you want to find the inverse. So there's a process that we follow. So let y equal to 2x minus 1. Then we're going to interchange. So you're going to put x is equal to 2y minus 1. And then the next part is to make y the subject of the formula. So I'm going to put 2y minus 1 is equal to x. So 2y is equal to x plus 1. So therefore, y is equal to x plus 1 over 2. So therefore, your inverse of this function is given by x plus 1 over 2. Right? So you want to find f inverse of 15. Right? I think it's 15 we had asked here. Yeah, 15. So f inverse of 15 here is going to be 15 plus 1 over 2, and you're going to get 16 over 2, so that's going to be 8. So that's your answer for f inverse of 15. Right? So that's inverse. And then this part B here, this is a composite function, right? And that is fh of 0, right? Now, when you guys see fh of 0, I want you to understand how you're going to read this. So what you need to do, you need to find h of 0 first. And when you get that answer, you're going to plug that into f, right? Now, check this. H of 0, right, is going to be 5 to the power 0. But anything raised to the power 0 is 1. So therefore, I'm going to take that answer 1, right? And I'm going to plug that into f, right? This is a composite function here. So all we're going to do, we're going to find f of 1, which is going to be 2 multiplied by 1 minus 1. So this is going to be 2 minus 1, and that's going to give me 1, right? So that's a composite function that we just worked out there. Right? As you all can realize, the paper can be pretty long, right? Now, here's what we want to do here. We have a function, it's a quadratic. This is our quadratic function here. And you want to complete the table and plot the graph, right? So, you know the function is given by, so f of x is given by x squared minus 2x minus 1. And if you want to work out for this value here, right, you're going to plug minus 1 into that formula. So this is going to be minus 1 squared minus 2 by minus 1 minus 1. So this is going to be 1 plus 2 minus 1, right? So 3 minus 1, you're going to get 2. So this value here is going to be 2, right? Then we need to plug 1 into the formula. So if I plug 1 into that formula, it is going to be 1 squared minus 2 by 1 minus 1. So this is going to be 1 minus 2 minus 1, right? And when you work this out here, you're going to get minus 2, right? So that's what we're going to have here. Right? Yes, guys, construction is on the syllabus, right? Right, I still have 2 more questions to do, right, guys? So I'm trying to do it as best as I can, right? Right. So I have this here. Right? Now I want to plot a graph, right? I want to plot a graph. So we did something similar last night, right? Where we had to plot a quadratic, right? So what I'm going to do, I'm just going to take the table and I'm going to carry it across here. Right? So all we're going to do, we're going to plot each of these points here, right? We're going to plot each of these points and you're going to get a quadratic. So the first point is minus 2, 7. So that's up here. Next point is minus 1, 2. Minus 1, 2 is here. Next point is 0, minus 1. That's here. Next point is 1 minus 2. That's here. Next point is 2 minus 1. 2 minus 1 is here. Next one is 3, 2. So that's up here. And then the last one here is 4, 7. Right, that's up here. Right? So clearly we can see that we have a quadratic. And what you guys have to do in the exam is actually try to draw a smooth curve passing through this thing here, right? It's kind of hard for me to draw a smooth curve, so I'm going to take a little help in order to do that. Right? Yeah, I'm just gonna stop there, right? But basically you have to draw a smooth curve passing through all of these points, right? Let me see something. If I would actually do this here, right? Alright, this is just me drawing this freehand here, right? That's the best I could come up with. If it's on paper, that's a different story, right? Alright, so what do we want to answer from this question again? So they want you to state, so we did something similar to this yesterday. What is the minimum value of the function? So from the graph, your lowest value for this function here is actually -2. So the minimum value of f of x is -2. That's the lowest value that f can take, right? So that's the answer for that part. And then the last part, they want the equation of the axis of symmetry. So remember, your axis of symmetry is that line that passes through your maximum or your minimum point. That's this line here. And if you notice, it's passing through 1. So the axis of symmetry is x is equal to 1. That's what it is. Your axis of symmetry is always x is equal to 1. X equal to something. Right? So that takes care of question 8. Question 9. So question 9 is based on this diagram here. So circle geometry comes every single year in the exam, right? So I want you to know that it comes every single year, right? So we have a diagram here, not drawn to scale. So PQ is a tangent to the circle at D, and they gave us some angles here, right? Now let's see what we have to do here. Determine each of the following angles. So we want X, Y, and Z. So let me ask you all a question. Could you all tell me what is X? And see if anybody can figure out what is X. What is angle X? Let's see what you all know. Right, so I've seen a lot of people getting the answer correct. So yes, right, so some people saying X is 70 degrees. I agree with that, right? Now what you're going to do, you're going to look at this point here. This here is a chord, right? Now if this angle is 140 degrees here, it means that this angle here, right, has to be half of 140. So you all are correct, the answer is 70 degrees. But when it comes to these questions, in order to get the 2 marks, you have to state the reason. So the reason in this case here is that the angle at the center is twice the angle at the circumference. You all need to see that in order to get the second marker, right? I'm not going to write it out here, but that's one of the rules for circle geometry. The angle at the center is equal to twice the angle at the circumference. What about angle Y? Anybody know what angle Y is? What is angle Y? Right? So some people saying the angle is 70 degrees too. I agree, but why is it 70 degrees? So the first one here, the angle at the center is twice the angle at the circumference. Right? What about this one? What's the reason for this one here? Why is that angle 70? Aha. So some of you are saying it, some of you are saying something that is incorrect. So in a question like this here, right? Don't think this question is as simple as you think it is. This is a chord, right? This is a tangent. So there's a rule that says that the angle between a chord and a tangent, which in this case is y, right? So this chord is DC here, right? This angle here we know is 70 degrees. So the rule is this, right? So angle y is actually 70 degrees, and the rule goes like this. The angle between a chord and a tangent is equal to the angle in the alternate segment. That's the rule you need to remember. So the angle between, right, a chord and a tangent is equal to the angle in the alternate segment. When I was in Form 5, this is one I could not remember word for word, right? But you need to remember word for word, all right? This is one of those things I learned the night before the exam, right? And what about angle Z? Could you all figure out what is angle Z? I saw some of you all saying it's an easy question. What is angle Z? Right? I'm telling you, circle theorem is going to come. It's been in the exam, in every single exam from 2018 to now, right? Right, somebody's given some good advice here. Make sure and answer the questions that you know how to do first, right? Don't jump to the hard questions and say you're going to do that first. Right, go to the easy questions first and then work from there, right? Right, so I've seen some answers here, so let me try to work it for you here, right? So those of you trying to figure this out, what we're gonna do, we can, you know, that 70 here, you can actually work out this angle here, right? That angle there, right, is actually 180 degrees minus 70 plus 65. Right, and that's going to give you $45 degrees, right? So that's 45 degrees. Now the next thing you need to notice now is that if we look here, we can identify a cyclic quadrilateral. Now there are some students who they just see a quadrilateral anywhere in the diagram and they think it's a cyclic quadrilateral. The vertices must be on the circle, right? Now, these angles here, angle Z and this 45 that we just worked out here, those are opposite angles. when you add up opposite angles in a cyclic quadrilateral, you should get 180. So therefore, to get angle Z, it's going to be 180 degrees minus 45 degrees, right? And you're going to get 135. So yes, you guys who worked it out, yep, 135 is the correct answer, right? 135 is the correct answer. Right? So let me see, let's move on to the next part of the question, which is a bearing question. So we have three buoys, A, B, and C, as markers, right, for a boat race in Carenage. AB is 14 kilometers, AC is 6 kilometers, and angle CAB is 110. And we want the bearing of B from A is 100 degrees. So the bearing of B from A is 100 degrees, right? So what that means is that this angle here, right? So the bearing of B, right? That's where you want to head. From is where you're going to draw your north line. So this angle here is 100 degrees, right? Now the first thing we want to do is to calculate this distance BC here, right? Anybody know what rule we're going to use there to calculate this thing here? Right, so one or two people saying it here in the chat, right? Yeah, we're going to use the cosine rule, right? So we normally use the cosine rule if we have an angle and we know the two sides on either side of the angle. That's the cosine rule. So you're going to use the cosine rule for this first part here. Now, what I taught my class is that you need to remember not just learning of the rule, but you need to know exactly what you're going to do when you're writing out the rule. So the side opposite the angle is BC. So you're going to say BC squared is equal to 6 squared plus 14 squared, right? Minus, it's going to be 2 times 6 times 14 multiplied by cosine 110, right? So this is the best way to learn it off. Make sure you know how to apply the formula. Don't just learn off the formula. I've seen students learn off the formula and still don't know what to do in the exam. So BC squared is equal to 36 plus 14 squared is 196. Yeah, this is 196 minus, so this is 2 by 6 by 14 by cosine 110, and this is going to be minus 57.5. So BC is equal, BC squared, sorry, is equal to 36 plus 196 plus 57.5. You're going to get 289.5, right? So therefore BC is the square root of this. So therefore BC is equal to about 17 kilometers, right? So that's the answer here, around 17, right? Hopefully the answer is correct, right? If you all see any errors, just let me know, right? So that's the distance BC here. Now, we want to calculate how far south B is from A. How far south B is from A. All right, so for this one here, let's now. I want to get a clean copy of the diagram. Let's now. right? So how far south B is from E, right? So what we're going to do, we're going to construct something here. Right? So how far south B is from E, right? That's this distance here you're trying to work out. That's what you want to work out, right? Now when I construct this here, what I'm really doing is constructing a right angle triangle, right? So this angle here is going to be 90. But remember, we just, in the question, they told you what this bearing was. That bearing here was 100, I think it was. Yeah, 100, right? So if this is 100 here and that's 90, it means that this angle here has to be 10 degrees, right? So the bearing, this is 100, right? And you have that 90 there. So therefore that angle there is going to be 10 degrees. Now, for this particular part here, you have a right angle triangle. So you know you're going to have to use one of these here. Sine, cosine, or tangent, right? It's a right angle, so we're using one of those things. So before you decide on what you're going to use, you need to label this thing here. So this side opposite here is what you're trying to figure out. That's your opposite side. The side opposite this here, the 90, is your hypotenuse. Right? So therefore this side here is your adjacent. Right? Now in terms of what we have, you want to calculate opposite and you know the hypotenuse. So you have opposite and you have hypotenuse. So therefore we must use sine. Right? You're going to use sine in order to work out this length here. So all you're going to do, you're going to say sine theta is equal to opposite over hypotenuse. So sine 10 is equal to the opposite, which we're trying to work out, over the hypotenuse, which is 14. So to work this out, just put sine 10 over 1, and then you're going to cross multiply. So therefore, opposite is equal to 14 multiplied by sine 10, right? And that's going to be about 2.43 kilometers, right? So that's the distance here. That's what they're looking for here. Right? So that's the answer for that part there. And the last part, they want us to calculate the bearing of E from C. The bearing of E from C. Now in a question like this, right, the from, you're going to put your note line, right? So the bearing of E from C, you want to know basically what is this angle here. That's what you want to know, right? Now, you don't need to do any special kind of calculation for this part. So the bearing of E from C. So what we know this angle is 110. We know this angle is 100. So what I could do, I can work out this angle here. Right? I can work out that angle. That angle there is going to be 360 degrees minus 110 plus 100. Right? And when I work this out, I'm going to get 360 minus right, so we're going to get 150 degrees here, right? 150 degrees. So that is this angle here. This angle is 150 degrees here. So if you want to work out this here, right, that's the bearing that we want to work out. The bearing of A from C, right? What we're going to make use of is that north lines are actually parallel to each other. So therefore, this angle here that we're trying to work out, right? When I add that to 150, I should get 180 degrees. Right? Those are what we call co-interior angles. So that bearing that we're looking for here is going to be 180 degrees minus 150 degrees, and you're going to get 30 degrees as your answer. Right? That's the answer we're looking for. Right? So that takes care of question 9. And the last question in this exam paper here now, it's your vectors and matrices question. Right? So I have 3 matrices here, A, B, and C. And the first part, we want to explain why the matrix product BA is not possible. Right? Now, what we need to do in a question like this, you need to be able to write down what is the order. So the order of a matrix is what is important here. Right, the order of a matrix. So this first one here, remember the order of a matrix is how many rows by how many columns. So in this one here, it is going to be a 3 by 2 matrix. So that's A. So A is a 3 by 2 matrix, right? Matrix B, you have 2 rows, 2 columns, so it's a 2 by 2. And matrix C is also a 2 by 2, right? So we want to know why BA is not possible. Now, if you take matrix B and you're multiplying it by A, it means that you're taking a 2 by 2 and you're multiplying that by A, which is a 3 by 2. Now, in order for 2 matrices to be multiplied, right, this number here has to be equal to this number here. In this case, it's not, right? So when you are answering this question or a question like that, you need to say that the number of columns in the first matrix is not equal to the number of rows in the second matrix. So those 2 matrices are what we call non-conformable matrices, right? The number of columns in the first matrix must equal to the number of rows in the second one. So that's how you're going to explain this, right? That's how you're going to explain this. The part 2 state the order of the product AB. So if you want to multiply A by B, is that possible? Yes, because these 2 numbers are the same, and the answer, right, is going to be a 3 by 2 matrix. So this one here is going to be a 3 by 2 matrix. That's the answer for that one. And then the last part, you want to work out what is the product BC. Right, what is the product B by C? So we have B. BC is what we're trying to work out, right? So B is minus 2, 3, 2, 6. And you're multiplying that by C, which is 5, 3, 4, minus 1. Right? So when you're multiplying matrices, remember it's always row by column. That's what you need to remember, right? So what I'm going to do, I'm going to take this row and I'm going to multiply it by this column here, right? So if you all want to understand what I'm doing, it's going to be minus 2 by 5, right? Plus 3 by 4. Right? So that's minus 10 plus 12. And I'm going to get 2. So the first number inside here is going to be 2. Next thing you're going to do, you're going to take this row, going to multiply by this column here. So that's going to be minus 2 multiplied by 3 plus 3 by minus 1. Right? So this is going to be minus 6 plus minus 3. So that's going to be minus 9. Right? Like I said, if you all see any errors, let me know. Right, so that takes care of the first row. Then we're going to take this row here now, and you're going to multiply by this column. So that's going to be 2 by 5, right, plus 6 by 4. Right, so that's 5 2s at 10 plus 24, which is 34. Right, so this here is going to be 34. And then last piece now, I'm going to take this row and I'm going to multiply by this column here. So that's going to be 2 by 3 plus 6 by minus 1. So that's 6, right? Plus minus 6. So I'm going to get 0. Right? So hopefully that is correct, right? I hope so. Right, so we have a next piece to do here. So that's that product there, right? This question is also kind of straightforward, right? So this question is asking about a singular matrix. So when you have a matrix and the matrix is singular, your determinant is equal to 0, right? So all you're going to do, if you want to figure out the value of x, you're going to say 12x multiplied by x, right, minus 6 by 12, right? That's how we calculate the determinant, but you know that the determinant is equal to 0. So this is going to be 12x squared minus 72 is equal to 0. So 12x squared is equal to 72, right? So x squared is equal to 72 over 12. So therefore x squared is equal to 6, right? So therefore, now the question asks for the possible values of x, right? Now x squared is equal to 6. So therefore x is equal to the square root of 6. Which is about 2.45, right? Now the question asking for values. Just remember, when you find square root, there's always a positive and a negative value. So this is going to be 2.45 and minus 2.45, right? So keep that in mind. Oh wait, sorry, one sec guys. I think I'm starting to get sleepy here, right? This is not a 12, this is a 2. One sec. I really find the answers working out kind of strange, eh? I don't like to bring questions where we have strange answers. So this should have been 2x squared is minus 72 is equal to 0, right? So 2x squared is equal to 72. X squared is equal to 72 over 2. X squared is equal to 36. So therefore x is equal to square root of 36. So we have two answers, positive 6 and we have a negative 6, right? I really find the answer is looking a little strange. Right, so my bad, starting to get a little sleepy too, yeah? Right? Alright, so let's do the last part of this paper, right? So before you all decide to bust it, just remember to hit like and subscribe, and don't forget to share my channel to as much people as you can, right? Alright, so now we have our last question here, which is on vectors, and generally speaking, students hate this question. So some of you all may not make it to the vectors question, but if you do, I need to show you how to handle a question like this. So we have a parallelogram, right? We have y is the midpoint of BC, and x is on B such that bx to xa is 1 to 2. All right, so it's a parallelogram. So what I would do if I were you, I'll write down vectors that I should know. So this vector should be B, and the one on top here should be A, because it's a parallelogram. Now the first part, they want the vector BA. So I've shown this to my class many times. If you want to get a vector BA, you're going to have to write out your vector equation first of all. So if you want to go from B to A, you must go from B to O, right? And then from O to A. That's what we need to do, right? So B to O is actually minus B plus OA, which is going to be A. So that's your answer for part A here. Very straightforward. The next thing we want to get the vector OY, right? You want to get the vector OY. So if you want to get OY, again, you're driving from one location to the next. So if you want to get OY, you can go from O to B, and then from B to Y. That's one route that you can take. So the vector B in this case is going to be B plus the vector BY. Now remember, BY, or the point Y, was the midpoint of BC. They told you that in the question. Y is a midpoint of BC. So therefore BY is actually a half of A. That's the answer there, right? So it's going to be right? So that's part B. And then the last part here, part C, you want to get the vector OX. So that's this vector here, right? Now that one is a little trickier, right? That one is a little trickier. Whenever you are dividing a line in a ratio, in this case 1 to 2, right? It means that this here can be broken up into 3 equal parts, right? So the vector, right, or the line AB is broken up into 3 equal parts because of this ratio here. So if I want to get what is OX, so I'll probably do this on the next page, but based on the diagram here, OX is equal to OB plus BX, right? That's how we're going to work that out. OX is OB plus BX. So let's see, actually I might be able to do it here. Yeah, let me do it on the next page, yes? So OX, right, is equal to OB plus BX, right? OB, we know that's vector B plus BX. Now what is BX? Now based on the line here, right, because the line is divided in a ratio 1 to 2, BX is actually 1/3 of BA. So this is going to be 1/3 of whatever BA was. But you worked out BA already. That's here. That's minus B plus A. Alright, so this here is going to be B plus, not plus, minus plus 1/3 A. Right, so this is going to be B minus 1/3 is going to be 2/3. So this is 2/3 B plus 1/3 A. Right? So that's the answer for that part of the question. And the final part, you want to prove that OX and Y are collinear. So students generally have issues with this, right? Students generally have issues with this. So what we're trying to do here, you're trying to prove, right, that this line here that passes through OX and Y, they are collinear, meaning that they are on the same straight line. Now, we have some of the information required in order for us to work this out already. We know what OX is. You work that out here. You already know what OY is, right? So what I'm going to do, I'm going to use those 2 points or those 2 vectors in order to prove this. So OY is B plus a half A. So OY is equal to B plus a half A, right? And we know what OX is. OX is this and OY is this. Once I'm able to show that one vector is a scalar multiple of the next vector, then we're going to prove that this thing is true, right? Now, if I look at these vectors here, I can say that, let me see which one is the longer vector. So OY, right, is equal to K times OX, right? And I need to figure out what that K is. So OY is B plus a half A, right, is equal to K times OX, which is 2/3 B plus 1/3 A, right? So now, if I want to get what K is, right, this K here, you all should recognize that K is actually 3/2. I don't know if you all, is it 3/2? No, wait, hold on, it's not 3/2. Yeah, it is 3/2, my bad. Right, it is 3/2, right? So this K has to be equal to 3/2. So what that means is that the vector OY, right, is equal to 3/2 times the vector OX, right? Now that's one part of your proof there. If you want to answer this question properly, right, what you have to do, you have to say 2 things. You have to say, this is what CXC is giving you the marks for. Since OY is a scalar multiple of OX, right? They are parallel. So you need to say that. The fact that one is a scalar multiple of the other, they are parallel. And then we're going to say, since they have the point O in common. Most students don't know how to answer a question like this. Since they have the point O in common, right, it means that O, X, and Y are collinear. Right? So that's the answer here for this particular question. Right? Alright guys, so I've done a full exam paper from my my set of questions, right? I just want to wish everybody good luck tomorrow in that exam. Take your time, read the questions carefully, try to answer the questions that you can do or you're comfortable with, right? If you're doing a calculation with your calculator, please double check the calculation one time. Don't wait till the end to check it over. It's not going to take you too long just to check over the answer, because you might type something wrong in the calculator, right? Like I said, good luck to everybody, right? Read your questions carefully, right? It's going to be okay, right? Don't get scared, right? So that's it, guys. That's the best I can do for you guys for tonight. Enjoy the rest of your afternoon, everybody. Be safe. Don't forget to like and subscribe my channel and share it to everybody, right? And I'll probably talk to you guys tomorrow, right? Take care, everybody.